Hello everyone. We are going to solve one algebraic problem here. If a square plus b square plus c square is equal to ab plus bc plus ca, we need to prove this. Okay, for this we have given a square plus b square plus c square is equal to ab plus bc plus ca. We can multiply both sides by the same number. So let us multiply by 2. 2 times a square plus b square plus c square is equal to 2 times ab plus bc plus ca. We can multiply by the same number, the value will not be changed. And while removing the bracket, we get 2a square plus 2b square plus 2c square is equal to 2ab plus 2bc plus 2ca we get. Okay, we are choosing here 2 to multiply because we are trying to obtain the perfect square expressions here so that the value of a, b and c can be obtained. So we multiply here both side by 2. Okay, let us transpose these 2ab twice bc and twice ca to the left hand side. We get 2a square plus twice b square plus twice c square. They will be minus while transposing. Twice ab minus twice bc minus twice ca is equal to 0. Or now we need to split the terms so that we can get the perfect square. So for this a square, let us split it as a square plus a square minus 2ab plus b square. Okay, one a square remain here. So again let us write here a square minus twice ca plus c square plus b square minus twice bc plus c square is equal to 0. Okay, 2a square is here, a square, 2b square is here is also b square, here is also b square. This 2b square is split here and kept in 2 places. 2c square also kept here in 2 places, c square plus c square. These terms are split here. Twice ab, twice ca and twice ab are as it is here. Now what we get? These 3 makes a perfect square here. These 3 terms make a perfect square here, and these 3 terms make a perfect square here. That is a minus b whole square plus a minus c whole square plus b minus c whole square is equal to 0. We get this. And it is a square term. It is also a square, it is also a square, and it will always give the positive since it is a square. It will also give the positive value since here it is square, and it also gives the positive value since here it is square. And the sum of positive values, the sum of non-zero values, non-zero positive values to be 0, it is not possible here. Unless the value of a minus b whole square is 0, a minus c whole square, its value is also 0, and b minus c whole square, its value should also be 0. Otherwise the sum cannot be 0. Non-zero, non-negative numbers while adding, it cannot be equal to 0. So what we get is that a minus b whole square is equal to 0, which implies a minus b is equal to 0, implies a is equal to b. Also a minus c is equal to a minus c whole square is also equal to 0. So a minus c is equal to 0, or implies a is equal to c. And similarly, this b minus c whole square, this term should also be 0. b minus c whole square is equal to 0, implies B minus C is equal to 0, implies B is equal to C. Okay, from these three now, what we get is that 1, 2 and 3, A is equal to B, A is equal to C and B is equal to C. So from these three we get from above that A is equal to B is equal to C. So now let us start to solve from the left hand side. Left hand side is equal to A by A plus C plus B by A plus A by B plus C plus B by A plus C plus C by A plus B. Okay, since A, B, C all are equal, this B and C also can be replaced by A. So what we get? A by A plus A plus B by A plus A, B also let us replace by A, plus C replaced by A plus B also replaced by A. So what we get? A by 2A plus A by 2A plus A by 2A, which is equal to 2A is the common denominator, A plus A plus A, which is equal to 3A divided by twice A, where A and A can be cancelled, so is equal to 3 by 2, which is the right hand side. Hence proved. Okay, this problem is from the algebra. In SEE, this question can be asked in 4 marks or it can be asked in 5 marks as well. First of all, mainly this term you have to know by the 2 we have to multiply here, and how these are splitted and perfect square are made. This step is important. These are splitted and makes a 3 perfect square here. And one important concept you have to use here, it is confused sometimes. If there are in the form of product, zero product property we can use, but here is plus sign, though how it can be zero? For this you have to understand this. These are the positive numbers. Since here is square, these are the positive numbers. The sum of the positive numbers cannot be zero. So all these terms should simultaneously 0. So A minus B whole square is also 0, A minus C whole square is also 0, and B minus C whole square also 0, which implies A is equal to B is equal to C. Now we can start from the left hand side, and if we replace B and C also by A, we can get the value 3 by 2, which will be proved. So it is very important question for the SEE. You may look. If you like our video, don't forget to subscribe it. Thank you.